like to join the Zoom meeting, the links are where they always are. And okie dokie. All right, so we're going to pick up right where we left off, which is with lesson 9. We finished 8 last time with replays and such in the correct place. Now, lesson 9, which is the next chapter, since this is one of the weird units where everything's broken up into chapters. It's functions, which we've already done functions because we did the unit from a previous year, the digital design, the digital scene project. But this is, so hopefully a lot of this is familiar. The idea of needing to needing to define a function and then call it as a two-step operation. But instead of using functions as the digital scene to repeat things, it's going to be more of a the update screen situation, which will be, you'll, like anything we do, you'll see as we go further, it'll be very common. So please to follow along. Okay, lesson 9, bubble 1. This is, should be super easy for what you know at this point. This is just another console log output project or bubble where it's the lyrics to a song, followed by a calling the function sing chorus twice, which that function is some more lyrics, but because it would happen frequently or multiple times, they've put it in the function definition, and then they can call it wherever they want that to happen. I don't know if this is the most common way to use a function. Any of these console log output puzzles, it's just for practice. It's not really the same type of problem solving, but all we need to do is put it sort of mindlessly where they tell us to put it, which is right there, there, and there. And then the output will then have the chorus. Wait, hold on. Am I doing something wrong? Sing chorus. Sing chorus is so wake me up, so wake me up. So wake me up. So wake me up. Okay. Why is it only doing it? No, it's right. It's not super easy to decipher these console log statements, or output, but the same, as a easy reminder of the concept of defining a function and then calling it. That's about all I hope for you to get out of that bubble. Okay, bubble 2. So we've done variables before, and this is a simple counting situation where we have a variable called count. And hold on, is this already working? Yeah. Okay, so we have a variable called count that is on up button is increasing and on down button is decreasing. And then we have a function called update screen. This update screen will be a common situation the rest of the way. And just like anytime you have a lot of code that happens repeatedly, it's useful to put it in a function, just build yourself a tool set. So update screen is called after the variables update. Okay, that's something we talked about before with variables, where you are updating the variables and then using those updated variables to either check something, or to check something, maybe not, but then update the output or update what's in the screen or what's on the screen. And instead of just having that all in the same event handler, we're putting it in a function so that it's not repeated. Okay, so that it's in its own tool, and the event handler can look more like my microphone not working. Look more like a sort of abstraction of what is happening rather than a bunch of lines of code. So we have update screens being declared. I mean, defined, same thing. Down at the bottom, sort of out of the way. And it's being called every time that. And why this is lame. Yeah, all right. Well, we'll hope that works. Okay, what do we need to do for this one? We need to change the program so it ends at 15 or greater, or if it's at -10 or less, which, I mean, this is more conditional stuff rather than function stuff, but these are end game situations, greater than or equal to 15, or less than equal to -10. We want the output to say the word clicks after the count. So right now the output label is just updated to whatever the new value of count is, but we want it to say the word clicks, so we can concatenate space clicks as the output. And there you go, that does that. And I think that's it. Okay, nothing too astounding for this one either. Really just stuff we've done in other units or other chapters. Okay, bubble 3, we've done the this app before, where we are checking password, usernames, and passwords. We want to put our update screen stuff in its own function, so we have the same tool. So we have, it's figuring out what is being repeated. Well, let's see what we have. Identical. For play, well, play button is the username and password situation. Then lemon mouse over and lime mouse over are two functions. And the way it starts, we have the first thing we have to do is put in a username and password to get to the actual game screen. A good trick when you're debugging your own program is to go into design mode, make the game screen the default screen. Then when you run it, that's where the program will start, so that you can work on things. Obviously switching it back, otherwise I don't think there's any way to get back to the password thing in this app. There might be, but either way, our two events are mouse over lemon and mouse over lime. Okay, they both update the score variable, or their relative one, lives and score. And I'm just going to delete the sound. You don't have to delete the sounds. Okay, then the next thing lemon does is checks score, and lime checks lives for game over status. And then they both have a random location situation. Okay, so that's clearly going in our new function, and they both have a update label command. So since they both share all of that, we can put that in its own function. So let's get a new function. Let's put it down here. I need to have some white space. I can't live without it. Okay, so our function, just like anything, you can call it whatever you want, but let's have some sort of naming convention like update screen and and update screen, and we can just grab all of the stuff from one of them, and assuming we have enough space to drag to, there we go, or cut and paste is fine also. Then we can just call update screen here. And we can call that up in lemon where we want it, and then just delete the lemon ones. Okay, and it still should work identically. Score, 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 lives. There we go. And I think that's probably all we need to update for. Update screen. Find repeated code, replace the blocks. New one called update screen. Declare once but call twice. Has a newly added code. How does the newly added update screen function help your code better organize, reduce the amount of repeated code? I mean, it does that. How does it? That's what it does. I don't know if you can explain how it does the thing. Okay, and once again, we'll talk about the regular pattern for any function or really event handler. Update the variable, then update the screen. Checking for an endgame condition in either in the event handler or in the function, the update screen function. Obviously in order. Okay, user interacts. Event handler changed the variable, and then screen is updated. This is an abstracted concept of how the program runs, or how any of our programs are going to run. Okay, and for the check for understanding, okay, in your words, describe the benefits of creating functions in your code. I mean, you could just listen to the words I've said or the words that have been written in the instructions. It's not, or some of the words from the last thing, terribly difficult. Why does my default microphone keep changing? Oh, okay. Well, again, we'll keep going. Okay, so let's jump on to lesson 10, which should be available to you. And you'll have plenty of time to come back to this if you need to. A good couple sentences for that should be plenty. Don't overthink it. Okay, so functions, the function definition doesn't matter, or excuse me, the order of the definitions don't matter. They really can go in your program code. They can be in any order or anywhere in your program code. That's fine. We tend to put them at the bottom of the program code just to get them out of the way. And let's see if we can. don't need to solve it again. Okay. And so, but the order that the functions are called matters. We almost always are going to our function, almost everything in our program code is usually going to be controlled by an event handler. But within an event handler, you may be calling several functions, in which case the order matters. We're not usually going to have functions just sort of free floating, fully, unprotected, as I say, on their own, unless it's some sort of setup function that you call at the beginning and you call at the, in an event somewhere. But for this, we are testing things, to show that the order matters. Okay, so the story is in order, starting with spring. So we just need to drag spring, summer, winter, autumn. And there you go. Not terribly difficult. Key takeaway is order functions are called matters. And I mean, none of these first ones are not terribly difficult, shouldn't be. And not just because we've done functions before. Okay, so this one we have, and you can switch to block mode. I don't know if yours comes in text mode, but we have 3 different functions here. One function is called roof, one is floor, one is lobby, and they're just, it's just ASCII art, just ASCII characters that are supposed to look like something. And we have, they're written out here, they're in order, but we need to add some floors. And the way it comes, we have one floor in the program, which is the windows and a line below it, but we want a total of 4 floors. So we just need to call floor 4 times. I suppose technically you could put it in a loop and do it 4 times, but that's not really necessary. And I guess I only copied it twice. There we go. And that's all there is there. At least 3 more. Okay, well, there we go. And keeping going. Bubble 3. Again, a lot more basic stuff. Just, okay, so it comes in text mode because it's broken. And you can see, okay, missing semicolon, it's a syntax error. So what it said, yeah, syntax error, meaning like a typing error. And even if you didn't know much about programming, you can tell that we're trying to call, there's only one function in this whole thing called buyApple, and it's case sensitive, meaning we can't have a space there, and this one needs to be a capital A. Then we can go to show blocks, and it should work. There we go. Okay, can you buy Apple enough times that you get the message saying you run out of money? Okay, so we need to fix the misspelling, debug the code to remove the errors, which are all gone. And our goal is to run out of money. So let's run buyApple a couple more times. How many more? Yeah, there we go. So you need a total of 6 buyApples in order to run out of money, because it's only checking for if dollars is greater than 0, which, since you're starting with 5, first 5 times you still have money. It's the 6th time that gets to the else condition. Text mode, and there you go. Okie dokie. All right, so we have, for this one, we have a declared, well, we have an update screen function, but we have it declared, but we're not calling it. And let's see, we have some event handlers for these buttons. Does anything work? No, nothing works. Although it is updating the variables. It's just not showing it because we're not updating the screen. Okay, so we have an update screen function. It's checking for the value of thumbs and setting an image less than 0, less than 10. So the only one is greater than 10, greater than or equal to 10. And it all looks good. We just need to have it happen. So we need to call update screen in our event handlers. And let's see if that works. Does it start at 5? Oh, it does start at 5. There we go. Not terribly difficult again. This is all stuff that you should probably be able to do from scratch as far as updating the image property. And is there even a sound? No, there's no sound. And I think that's it for this one. That's it. All right. Bubble 5, functions have a repeated code. If you ever same pieces of code over and over, you should declare a function, which is all we've been talking about so far. Do this, rewrite the program functions. This program to use functions rather than repeated code. Read the program, identify blocks. Okay, so this again is a lot like when we did choosing where to write functions is a lot like when we did the text compression widget, where you're looking for repeated things, but the longer the repeat, the better, but at a cost to how many times you get to use it. So let's see here. We have morning, slept in, noon. Okay, scratch up. So it looks like the daily routine is identical all the way down. Let's block. Okay, let's call function. What's a good name for it? Let's get my cat schedule, and let's put one of them in that, and then we can just call nope. Call that anywhere we want that full chunk to happen. That should have the same output. Yep, there we go. And I think that's it. Okay, debugging variable scope functions. Okay, creating variables once at the top outside the function or on event. Okay, this again was definitely discussed in the variables section of the unit, but it's all related. So generally speaking, we want to go with global variables, meaning declared at the top of the function, or excuse me, at the top of the program code, and then just updated inside of functions or event handlers. Careful about using local variables, meaning the var is inside of the function definition or event handler. When in doubt, make it global, declare it globally, and then update it inside the function. But no matter what, any function can only have var one time. Okay. Adding local variables and debugging. We'll eventually use, it most likely be confusing. Yeah, accidentally adding. Yeah, so there are times for local variables, but there is never a time where you would have var both places. If you're not sure, make it a global variable, declare it at the top, and then update it. Just do updating, which is saying the name of variable equals or gets, and then whatever its new value is. And we're up to 8, 7. Okay, the program should buy an apple every time an apple's clicked, but doesn't seem to be working. Run the code to see how it works. Let's see what happens. We have, I had undefined, now I have, okay. So we have debug the scope. So we have two variables, dollar starts at 5, apple starts at 0. Every time we click the apple, we run by apple. So all we have is by apple. Set text to I had blank apples. Dollars gets dollars -1, apples gets apples +1, and then the new value and sets the dollars label. This is super obvious. We have var inside of our function definition and outside of. It actually, no, it needs to be global in this case, because if you write var, you're wiping previous knowledge of it. So we are going to just get rid of var inside of the function definition. And it works. Obviously, we would need some sort of conditional to check for $0 and have some sort of different situation for that. But this does work. Setting the text to the previous value of apples, changing the values of the variables, and then setting the now I have text area to the new value. Okay, so Bubble 8 is another one where there are 3 different apps that we're going to do all of them. They're all pretty short, just like the last one. So this is the ticket price app. We saw this one before, but now we have the task of sort of refactoring it using update screen. Okay, so let's see what we have. We have a bunch of global variables. Good, dollars at 0, tickets at 0, adult price, child price, senior price. Adult button, we update tickets goes up by 1 and dollars goes up by adult price. If so, we have a sold out situation, and then we update some screen stuff, and it even has this comment here that tells us that this is update screen. So let's make a new function called update screen. Let's define a function, call it update screen, and we can just put all of our update screen stuff in that. And we can just call that function. And the other event handlers are just going to be the same thing, except with child price. And senior price. Because everything else should be, I got the bug. refresh. Everything else is the same. We're updating tickets by one, or incrementing tickets by one. We are oh no. That's what happens when it breaks. Child, cheating child, and senior. And let's see what happens. Adult. Good. Are we supposed to hide things? Add coach. Okay. So one added piece of functionality that I need you to do is, so this is our sold out situation. When that sold out situation happens, so there's a label here that when you start it, it's hidden. And that's because in design mode, when it says hidden is true. Okay. But just like any of the other properties, you can change them as the program runs, which is what happens when the number of tickets gets to 20. It shows that. I think it's a good idea, and so we're going to, when it gets to sold out, I want to hide these buttons so the user can't keep adding tickets. Okay, a lot of app design is just keeping the user from breaking the stuff. And so this is our sold out situation. So let's do some set property of adult button. It's property of, okay, so depending on the property, the value that it's setting will be something else. And the hidden property is a true false binary, where true is it's hidden, false is it's showing. But we need to do hidden equals true, or hidden is set to true for adult button, child button, and senior button. Okay, and now we get to 20. It says sold out, and there are no more buttons. And even though they're hidden, or hiding them isn't just visually hiding them, making them invisible, it's making them go away so they can't be accessed, which is the point. Could be some sort of reset button, but that's not super necessary here. Add code, senior buttons work. They should total number, money collected, make sure, okay. And that's it for 8, or that's it for the first one for 8A. So you need to click back up at the top on bubble 8 so we can look at the next one, basketball stats app. All right, so helps keep track of to learn more about basketball. This is Wikipedia, but yeah, lovely. Some of the buttons already have working code inside. The other buttons work very similarly. Rather than write repeated code, practice create a function for on event, run an app, see how it works. Okay, let's see what happens. We hit run. We click on this. It doesn't do anything. This. Okay, so it's saying it gives us well, it's actually pretty cool. Gives us an opportunity to decide whether or not it's a miss. And it looks like, wow, this is pretty cool. Looks like it is updating. Wow, this is actually an interesting app with you could even add more statistics to it. Let's see how much we have repeated. Well, this is quite a bit of code. Okay, so repeat the code under, read the code under 3-point button and mid-range button and declare which line belongs on a function. All right, this may take a second. Read the code under make button and miss button, declare which lines need to be a function, declare the function, call function, and look for opportunities to incorporate more functions. Okay, functions. So let's see what we've got. We've got a bunch of variables: total points, field goal average, field goal made, 3-point average, 3-point made, field goal percent, 3-point shot, false. Interesting. Sure. Okay, so one of our variables is a Boolean. And so it looks like, okay, so the way we get it, one of the short, one of the blue buttons works, and that is, this is called mid-range, right elbow, left elbow, layup, 3-point, corner, 3-point, and 3-point button, which it's a little bit shortened, but you can always click on design mode to find what these images are called, these are what the element ID is for each of these. And so let's think about what, okay, so this is make button, if 3-point, so this is where, so every time miss button update, wow, it's a lot going, to declare a function that will allow shots button. All right, so the miss button works and the make button works. The question is, we need to hide and show it at the correct times. And we need to put whether 3-point is true or 3-point is false in each one. That that Boolean is used to determine whether it goes into this, okay, for the make situation, whether it goes into this part of the condition or this part of the conditional. And it's starting in a situation where the entire app is designed to run around, to work around the idea that it's not a 3-point shot. If it is a 3-point shot, it switches it to true. And then when you get the opportunity to run make or miss, which are these two buttons here, it will either go into the top half or the bottom half, whether if it's a 3-point or not, else being the 2-point situation. But if it goes into the 3-point one, and this is actually kind of clever, it resets it to false. So the beginning, anytime you see the make or miss situation, or anytime before you've clicked on any one of the buttons, it's starting assuming that it's not a 3-point shot, starting assuming it's a false. Then when you run it, which this is actually a really clever way of setting up an app where it's only when you click on the button, the only thing it really does is show you the buttons or show you the make or miss button. It decides whether it's a 3-point or not, and then it shows you the buttons. And based on these buttons, whether you click on make or miss, it checks to see what it is, either a 3-point or not a 3-point. And the way a Boolean is used, okay, so normally we would say something like if clicks is greater than something and have a conditional check for a value. Like if clicks is greater than 2, do this one thing, otherwise do this. With Booleans, you just check that name, okay? Because the Boolean is either going to be true or false, not the word true or false, the concept true or false. You just say if, and then say the name of that variable. If it's true, it will run this half of the condition, the conditional. If it's false, it will run this half because it's an if else. And then it's if it is the 3 point and it goes into changing the variables for the 3 point situation, when it's done changing the variables, it switches 3 point shot back to false so that the next time it runs, it's starting from the position that it's false, that it's not a 3 point. If it's already false and it goes into the second half of the condition, it doesn't need to switch it back to false. It's already false. And it doesn't matter whether you set it up assuming the shot was a 3 point or not. The rest of the code needs to be built for it, though. Okay, so both of these make miss ones. Check to see if 3 point shot is true, and then do the appropriate variable changing. Then runs update points and update info, which update points and update info already work, and then hides all the buttons and the label. Okay, this is super clever. I love this app. That it, I mean, just the user interface, user experience is outstanding. That it only lets the user access these buttons when it's appropriate, and we just need to make the other buttons work. Everything already works. We need to declare a function that will allow all the shot buttons to work without repeating code. Okay, so we have all the shot buttons is lay up this one. And so what are the things that are going to go in every shot? Show, hey guys, like 5 more minutes, 10 more minutes, 20 more minutes. Okay. Every time, no matter which the shot is, we need to show both the make and miss button and show the label there. So that's definitely going to go in our update screen. Yeah. But the 3 point shot true is only going to go in the other 3 point shot. And we can save all of these. We need a new function that has a good name. What we call this, show buttons. And okay, so show buttons is needs to be in every one of the shots. The function call for show buttons needs to be in every different shot button event handler, but only corner 3 and 3 point need set 3 point as true. Show buttons, show buttons, show buttons, and show buttons. Okay, and what else is repeated? Total field goal is repeated. All of these things are repeated both times. Yeah, so let's just call this, that's a good one. Since these both happen twice, And I'd say twice is sort of the gray area as to whether or not it's worth being in a function. Later on, when we get to what are they called? Arguments, or using more advanced arguments, it makes sense. Or return functions, where you can sort of segment different aspects of functions. It will definitely make sense to have a new function for it. But again, like the text compression thing, it usually depends how many times you use something. Okay, let's just call this update screen because it's fun. And we can, any place we have, what is happening? I break it, whatever, that's what it looks like. And so any place we have that same chunk, which is here, update screen, goes there, and same thing here. Goes there. Okay, so we simplified things by making an update screen function, which is just hiding the buttons, and calling update points and update field goal info. Yeah, if you're kind of confused about the app as a whole, don't feel bad. This is, I would say, probably the most advanced app that I've seen in App Lab as far as a practice app. Students have made more complex apps than this in their own projects. But as far as giving you an example to modify, this is, I mean, I love the functionality of this app. I love how it solves the problem of if it's only keeping track of 3-point averages, it doesn't matter which button it clicks, but the green buttons set 3-point shot to true. The other ones don't need to say 3-point shot is false, because the app is designed to start with 3-point shot being false. And if it is true, meaning either one of these make or miss, where 3-point is true, it sets it back to false. So the next time through, we're assuming that 3-point shot is false, unless otherwise stated, unless otherwise changed. Okay, and I mean, I guess we could go one more and say 3-point shot false, total field goal average and total field goal made are in both of these. Although we have total field goal average, total field goal, oh no, that's total field goal attempt, total field goal made. So these happen twice, but hold on, does this make sense? Total field goal attempt, total 3 attempt. Oh, in miss, you don't need to increase the made, you just increase attempt. So are there other field goal up, 3 field goal up, field goal FGA up, 3 field goal up? I mean, I guess these 2 lines of code happen twice. I don't know if that really makes sense. I'd say that doesn't make sense to give it its own function. Let's see what the teacher's answers look like. I never actually look at these. 3-point, 3-point, show buttons. So ugh, I don't know if I like this. The example that code gives me is the fact that update points, and actually this isn't any better. It has update points and update info in its own function, but it could just be in this one. And actually, I would argue mine is better. Okay, so we're gonna do that one. Okay, so key concepts here are, I mean, we'll say advanced concepts are using a Boolean to set a state, a true false state, and running. So on the event handler, it's setting the state and then just showing the buttons, and that's the only calculation that happens at that point. It's not until the make or miss button is clicked that it even checks for three-point trueness. And then the math here for averages and totals is all done in this area. Set number FG output. Oh, field goal percent output is the name of the text area. I was like, are they doing modular arithmetic? They are not. They are just using the percent sign. Okay, so let's see here. Make this 3-point. Okay. Yeah, that's great. And I think that's it for this one. Yeah, great. Okay, so let's go back to bubble 8 and do the last one. Okay, so we've seen this one before, but we're going to try and simplify it a little bit. So we have program keeps track of how hydrated you are. One button already working. 3 buttons similarly. Update screen. Inside it, run the program, see how it works. Read the code for cup button carefully. Figure out what should be an update screen. Declare update screen function. Add the code to make bottle decrease and increase. Okay, so this one I think is probably going to be a lot easier than the last one. We have an amount of water, an amount of cups consumed, total number of workouts, cup, bottle, running, and weights all affect the amount of hydration, with cup and bottle going up and running and weights going down. And we actually could make this even more simple than they even imagine by putting running and weights as a negative number. Then hydration can always be plus equals that variable, or gets gets total water plus that amount. And because it's a negative, running and weights make that number go down. But let's not overthink it at this point. Okay, so the cup button, cups consumed, goes up by 1. Total water goes up by the amount a cup is supposed to do. And then we update the screen with the variables. And let's go ahead, and it's clear we're supposed to put that in our own new separated function called update screen. And we put that there. And let's copy that. And we can put that where we took it from. And we're at least back to where we were. Okay. And so the other ones, we just need to, for bottle, we need to update cups consumed goes up by 1. Total water goes up by bottle. And run update screen. Okay, the other ones are running and waits. And that needs to update. Coin 2. Are these all coin 2? They are all coin 2. Okay, so it's going to be the same framework, except it's not cups consume, it's workouts. Gets workouts +1. And we want total water to go to get total water minus. Minus, which one are we doing here? Running. And then let's get rid of this. And then the weights button is the last one, which we don't need the sound twice. Workouts also goes up by 1, and total water goes down by weights. And I think that's probably it for this one. And up a bunch, up a bunch, up a little, down a little, down a little, down a lot, down a little. Okay, I think that's it for this one. And bubble 9, just some more informative stuff. When to create a function. And I have a feeling it's going to be related to this. Let's see what we have here. Okay, so when to create a function. When you create functions, you never create a function, your code be difficult to read. I don't know. Okay, so writing functions. Hey guys, gentlemen, quiet for like literally 3 more minutes. Okay, if you never create functions, your code will be gross. If you are creating functions after you write your code, you're just refactoring, and that's what we've been doing most of these. It's fine. It's good for simplifying. It's good for leaving a nice, tidy package for yourself or other people in the future to look at. Okay, creating functions before, or excuse me, during. This is, I would say, the most common way that as you're solving the problem, you are figuring out what chunks of code you want as tools in your toolbox, and writing things before. This is really only if we're doing like a planning guide, that sort of thing. And I don't know if it's that much better than writing them during. Okay. Hopefully at some point you're solving problems like just as fast as you can type, that sort of thing, and jumping right into program code from the beginning. The planning guides are good for most of you at this stage in your development. Okay, bubble 10, some pseudocode stuff. This is your pseudocode reference, which you'll always have. And so this is just about procedure name, the same thing as a function, and then block of statements. Okay, what will be displayed after the code segment is run? Days of the week gets Saturday, or day of the week gets Saturday, day of the week gets Monday. This is a strange way of writing the same thing, but we know how functions work. Okay, if day of the week is Saturday or day of the week is Sunday, run weekend or, okay, so these are functions, run weekend, otherwise run weekday. We know how functions work. Day of the week gets Saturday, day of the week gets Monday. Day of the week is currently Monday. Because we've rewritten day of the week with Monday, this first line of code is completely irrelevant. There is no knowledge of day of the week gets Saturday. So as this chunk of code runs, day of the week is Monday. Okay, so if day of the week is Saturday or day of the week is Sunday, run weekend, otherwise run weekday. So we go down to this, the function definition for weekday, display school day. So that's what we're hoping is the answer. And I don't want to answer it, but the answer is school day. Okay, as long as all of you should have been able to solve that if it was in App Lab program code. I think here it's just really about practicing what pseudocode looks like, function or variable assignments, conditional in block form, and functions in block form. Procedure just means function. Okay, and that's it for 9 and 10. Go ahead and get those done if you haven't already. Go.